Hey guys, welcome once again. We have already seen what is switch mode power supply and its advantages over linear power supply in previous video. We had also gone through the block diagram of SMPS. If you haven't seen it yet, you may watch it by clicking on this card above. In this video, we'll see what are the steps to be followed while designing any SMPS. Well, SMPS is kinda complicated to understand and design too. And if you follow the proper methodology and steps while designing, you'll have your own SMPS working properly in your hands. SMPS is an AC to DC converter. Just think about an example. If you do the power dissipation calculations of a circuit and you don't know the components, the power handling capacity or their safe operating area, then it will be of no use, right? For that reason, we must follow a specific order while designing, and flow becomes much easier by determining the necessary information beforehand. Now let's go through a flowchart for designing of an SMPS. First of all, we'll determine which topology has to be used. Topology means the proper arrangement of power components like transistor, diodes, filters, etc. within the design. Next is component calculation. We may also call it as black box calculation. After that is designing the magnetic materials like transformers or inductors and their wire gauge. Later on, designing an output filter and rectifier. Then comes driver design. Then there is controller design. Then designing an output feedback stage. After that, designing a small startup circuitry. Then we have to design some sort of protection circuitry to prevent the damaging of components. And last but not least is thermal analysis. Now let's see the topology selection. It is the most important step amongst all of them. As I have mentioned in earlier video, these topologies are divided into two parts, like isolated and non-isolated one. The difference between them is isolated topology creates an electrical separation between input and output. That means it contains a transformer in between. If you take a look at this table, it contains the necessary information about the selection of topology. First here non-isolated type of topologies and rest are isolated. Here they have mentioned power range, input voltage range, efficiency, etc. These values are different in different references. If you refer this table, buck topology can be used up to 1000 watts of power, and it simply steps down the input voltage. Next is boost topology. It cannot be used in high wattage application because as power increases, the peak current increases. In SMPS, we generally use TO220 package of transistor, and according to their datasheet, it has peak current limit of around 20 ampere. And if this value exceeds, the probability of damaging the components becomes very high, and hence it cannot be used above 150 watts. And same goes for the buck boost topology. According to this table, transformer isolation is important above 40 volt DC input voltage, because these topologies will give a fine protection against high power application. The first in isolated topologies is flyback converter, but because of peak current limitation, it also cannot be used above 150 watts. Between output power of 150 watt and 500 watt, hub bridge topology can be used. If you see the topology, there are two transistors in series which act as active switches, and they place half of the input voltage across the primary winding of transformer and transistor. Hence, it can handle fairly high peak currents. For above 500 watts, full bridge topology is used. But one thing keep in mind, as we deal with high power, component cost also increases. Next step is black box calculation. This step contains all the necessary calculation by using proper formulae for components which we need in respective converter topologies. There are different parameters like input power, output power, average input currents, and selecting power switches. We'll go through these steps in detail when we'll do the full design of each topology in further videos. Next step contains design of magnetic elements. Magnetic elements are backbone of SMPS. It includes the appropriate core selection, styles and size of core, winding techniques, voltage spikes calculation, and settling time of converter. The output we get from the switching element is in the pulsating form, and we need to convert it in pure DC form by using diode rectifiers and filter capacitor. For that purpose, output filter and rectifier designing is necessary. Next is driver designing. To switch on and off the active switch, a driver is used. If you take a look at buck, half bridge or any topology in which source, if you are using MOSFET, is in floating condition, then we'll definitely need a driver IC for that. Some driver ICs also provide isolation between controller and main circuit. The controller is the heart of the SMPS system. It provides the necessary duty cycle to switching element in pulse width modulated way. It helps to regulate the output. The term output regulation is used to define the stability of output of an SMPS. Any PWM IC like LM3842 or LM3524 is used for this purpose. Next is feedback loop. Every power supply needs a feedback to regulate its output. By comparing reference and feedback, controller regulates the output. And generally, we use negative feedback. Then startup circuitry is necessary to power up the controller initially. Then it will provide the PWM wave and regulation. There are a lot of protection circuits like overvoltage protection, short circuit protection, overload protection, and this protection depends on the particular application. Next is thermal analysis, which is very important because while designing a power supply, we are dealing with very high power. And to withstand this type of environments, thermal analysis has to be done. Well, that was all about the basic things you need to consider while designing any SMPS, and we'll definitely discuss these design steps in detail in next videos too. For that, stay tuned, and if you have any questions, you may ask in comment sections. And hit the like button if you like this video, and subscribe to my channel so that you'll get the updates about my new videos. Watch my previous videos if you have any interest in technology, and I'm sure you'll definitely find some interesting information. And finally, thanks for watching.